All right, folks. I'll probably erase this actually because this is sort of what I'm calling a bonus problem from problem set number 2. Um, but I realized that I had assigned a couple of quotient rule problems and I did not do any quotient rules in those solutions, so I figured I'll do one more. All right. So I just named this function. This letter looks kind of like a W. W would be kind of have that little point right there, and so this is a lowercase omega. All right, Greek letter lowercase omega. Why did I choose that letter? I have no idea. So here we've got omega of x is equal to e to the x plus e to the negative x over tangent of x. Okay, and we want to find omega prime. So the derivative of this function. I'm actually going to have to do a little bit of a chain rule for a piece of this, all right? And as a quotient rule problem, I mean, normally you teach one before the other, but we're kind of diving in. We're doing a bunch, so I'll mention where we're going to have to use that, all right? My quotient rule is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom over g squared. Alrighty, so there we go. So I might want to set some stuff up, find the derivatives probably for this one. So let me set it up like that. So here I'm going to say let f of x equal our top. So with quotient rule, if you're using the f and g, f is always the top, g is always the bottom. So let f of x equal e to the x plus e to the negative x. All right, and let me take, before I do g, let me take the derivative of that right now. So then f prime of x is, I've got a sum here, so a sum between two terms is no big deal, just do the derivative of each term. The derivative of e to the x is e to the x, right? And then I'm going to be adding that to the derivative of e to the negative x. E to the negative x, right, if, let's just do that on the side here. If I've got y equals e to the negative x, let me call that e to the u, right, if u equals negative x. So just do a quick little chain rule right here. Then dy dx, in other words, the derivative of this thing, is going to be, I've got e to the u, always produces a copy of itself, so I've got e to the u times u prime, right? That's kind of how our chain rule works right there. And so let me just plug my u's back in now. So e to the u is e to the negative x. So that should typically happen when you're taking the derivative of e to some exponent, it sort of returns itself. Multiply that by the derivative of u now. The derivative of this thing is just sort of that coefficient, that leading -1 that lives out there. And so there we go. So times -1. All right, which we can clean up as just negative e to the negative x. So that's one you might sort of want to commit to memory a little bit. So the derivative of e to the x is a positive e to the x. The derivative of e to the negative x is negative e to the negative x. And so since I'm adding that negative e, let me just swap that out and write minus e to the negative x. All right. Where sometimes students will get lost right there is they get so trapped with that e, that minus sign that appeared out front, that they'll put the minus sign there and then forget that that's still e to the negative x, right? So that function didn't change. So that's what we've got right there. So f and f prime look real similar, except the plus sign turned into a minus sign. From there, we've got let g of x equal our tangent. And then derivative of tangent, we recall from class, is secant squared of x. All right, so I've got all my pieces right there. I've got my Superman badge right there. And so I'm just going to plug things in. So our derivative, let me set up my big fraction bar, I hope that's long enough, is g, so tangent of x, times f prime, so times e to the x minus e to the minus x. So I've got g times f prime minus f, which is this, e to the x plus e to the minus x, wrap that in parentheses, multiplied by g prime, which is our secant squared of x out there, all right? And then what's that all divided by? That's all divided by g squared, which is tangent squared of x. Tan squared of x. Okay, so if I'm writing this on paper, of course, I probably maybe hopefully show this thing, hopefully show that thing, or something, use some denotation or somewhere. Got something there. And of course on paper then, if we're going to show our work, we're not going to erase anything. Let me erase that stuff right now though, just so I can clean up the board and try to simplify this, because that looks a little bit ugly. But let's see if there's anything that we can fix up here. What could I do? I might start distributing stuff. Tangent we know is sine over cosine. Secant is 1 over cosine. So could that help us at all? First, let me distribute everything, get rid of all the parentheses. So here I'm going to pull my e functions up front. So I've got e to the x times tangent of x. Then I've got, let's say, minus e to the negative x times tangent of x. Okay, so that's distributing the tangent to both of those things. What's happening over here? Then I've got minus e to the x times secant squared of x. All right, and then I've got, this is e to the negative x times secant squared, so that'll be a positive term. I'm subtracting everything over here, though, so that's going to have a minus in front of it. Minus e to the minus x times secant squared of x, and that's all over tangent squared of x. Okay, looking kind of a mess. Where do we go from here? I've got e to the x's. I could try to factor out, group up some tangents and some secants. I'm having different inspiration. Let me erase this whole thing. And let me break up, since I'm adding here over this denominator, I can break this up as this term over that term. Why do I want to do this? Over here I've got a tangent over a tangent squared. So if I can separate these, I can cancel tangents. Right now I can't do that because this guy doesn't have any tangents. Also, if I can separate that, I've got secant squared over tangent squared. So I've got 2 copies of each of those functions, so maybe that will be helpful. And also, since both of them have cosines, maybe I can get lucky and try to cancel out some of those cosines that are involved. Could I have done that with what I just erased? Maybe, but by breaking it up, I was too afraid I was going to kind of mix and match things. So what I want to do here is, essentially, I'm calling that A up top, this product, and minus B over C, right? And so is it fair if I'm subtracting like that to split that up as A over C minus B over C? And sometimes folks, I feel like, are a little bit uncomfortable trying to do that. They're afraid, like, am I allowed to just break that up like that? And I can, though, and it's easier to see that you can do that if you do this back in reverse. Because if I was asked to do this subtraction, I'd say, well, I have the common denominator, right? So then I'm just subtracting those numerators over that denominator, and that's fine. So let me do that. So let me separate that. So I'm going to write equals tan of x times my e to the x minus e to the negative x over tan squared of x. And then over here I'm subtracting, and then that numerator right there. Let me pull the secant up. Secant squared of x times e to the x plus e to the minus x. Also still over another copy of tan squared. All right, there we go. So that's kind of okay. What do I have over here? Tangent and tan squared, I can cancel the tan from top and bottom, right? So to do that, let me just erase one of them. I'll show the work for a second, but tan squared of x was tan of x times tan of x. Cancel, cancel, so I'm left with just the tangent of x. Okay, so good. Let's do that. That looks a little bit nicer. And let me just play around with this thing a little bit. Secant squared of x is 1 over cosine squared of x, right? And I'm dividing that by tangent squared of x, which is sine squared of x over cosine squared of x, right? So decomposing those guys into their quotients right there, since both of those denominators right there are cosine squareds, they're going to cancel out. And so what I'm looking at now, if you want to see that happen, you can flip and multiply. So 1 over cosine squared of x times the reciprocal of that thing down there, cosine squared of x over sine squared of x. Cosines cancel, right? And so I've got 1 over sine squared of x, which is the reciprocal of sine is cosecant, so I've got cosecant squared of x. Okay, cool. Over here I have this tangent is living in a denominator, so I've got a 1 over tangent. Reciprocal of tangent is cotan. So let me just get rid of the fraction right here and say I've got cotan of x. That was just a single copy right there. It wasn't being squared. And over here, secant squared over tangent squared, we just claimed as cosecant squared. So let me get rid of all that and give us a cosecant squared of x. Put my minus sign a little bit better. and maybe that's some sort of cleaned up answer, right? So notice we had the big messy quotient. I was able to sort of clean up the quotient. So does that look cool? Sure, it looks cool to me. Could I rearrange these terms? Yeah. So now I could do what I did earlier, maybe distribute everything, collect coefficients outside of e to the x, right? So here I've got a cotan minus cosecant squared, both being multiplied by e to the x. I've got those same functions being multiplied by the e to the minus x, but I'll probably leave that right there. Anyway, this was not an assigned problem. Kind of an exercise at first, just using the quotient rule, plugging everything in where it belongs, which is sort of half the battle. And then I want to say it's sort of an art more than a science to decide, what a good final answer looks like. So that's kind of debatable. Use your best, try to clean it up a little bit. If you run into, if it starts looking worse, like was happening to me before, whatever. But anyway, you can always ask me questions or email me in advance. Hey, does this look like a good final answer? All right, guys, I'm inspired by one of my old videos where I just on the spot thought about extra credit. I mentioned at the beginning of this video, what is this Greek letter? All right, it's not a W, it's a Greek letter, it's a lowercase. I think it's a lowercase. So send me that in an email, just say extra credit, whatever, include it in the video of the other or with the other extra credit. If you didn't see the other one, go scour through some of these solution videos. Not huge points, but I'm kind of just doing this for fun to see who watches this stuff. Okay, cool.